Okay, sample problems. They're going to come at you with some different language, and I just don't want the language to throw you off. The math is challenging enough. So the question is, are the expressions, see that's an expression, this is a mathematical expression, are those two things equivalent? Now, see these two markers right here? Wait a minute, right here. They're red. These are equivalent. This one's in this position, this one's in this position. They're not equal. They're different things, but they're equivalent. So that's kind of a geometry question. I could get technical and say, are these two, the purple and the red, equivalent? No, this one's purple, this one's red. Anyways, with that being said, we just want to know, are they basically the same? How do you do that? Well, you're going to have to simplify this, simplify this. Now this is already simplified. Well, no, it's not. There's a little something I can do there. So anyways, looking ahead. So all they're really saying is factor this completely, simplify it, factor, 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 factor. Same thing here. See if you get the same answers. So let's start here. Now some of you are like, oh, take the x cubed out. No, 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 no. See, that's separated by subtraction and addition. Never works. That's what I'm saying. Factor, 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 factor. So I'm going to look at the top and say, what can I take out? I'll map a set. So I take out an x. I'm left with x squared minus 16. Now I notice this. Don't quit on something just because you did a little something to it. It leaves you with a difference of two squares. So I'm x minus 4, x plus 4, all over. Now how much can I take out of that? Well, a 4 and a 16, I can take a 4 out. This has 3 x's, this has 4, so I can take out 3. And I'd be left with x, because this times this would give me this, plus 4, because 4 times 4 is 16. I took the x cubed out, so there's nothing left. Now, am I done simplifying this? No, now I can factor. They're the same things. Notice this. I got an x here and x cubed here. That's the same thing as x times x times x with a 4 in front of it. And I can take this little x out and that little x out. So I'd be left with x minus 4 all over 4x squared. How come I can't take these 4's out? How come I can't go here? Because of that. So you're done. Now let's simplify this one. The only thing I see going on here is I could rewrite this. Now you don't have to rewrite it. You can just do it because your brain's going to see it. It's the same thing as that. So I'm expanding it so you can see what we're doing here. So I'm going to take out this x and that x because they're both connected to things in the numerator by multiplication. And I'd be left with x minus 4 all over 4x. And then I'd say, nope, they're not equivalent, okay? Now some of you might look this way, and remember from Algebra 1, if I have 2 up here, I got 1 there, that's just going to leave me with 1 down here. It's a little trick. It's not much of a trick, but it's the same thing. So, all right, let me pause that. Okay? Same problem. So, why did I write it down twice? Well, some of you are going to go at it a little different, and that's okay, as long as you just don't break the rules of math. So, student number 1 looks at this, and they're like, hey, I see it's a little different looking, but that's a difference of 2 squares. So they're going to go like this. 1 plus 1 minus, take the square root of 4, 2 and 2, take the square root of x squared, x and x, perfect. And then they're going to factor this denominator here. Now we've got a 1, so we're going to go like this. We're going to say, aha, x and x, 2 factors of negative 10 that add up to 3. I know a 5 and a 2 are going to create my 3, but the bigger one needs to be positive. So boom, boom. All right. So now we've got a lesson that I need to teach you right now, okay? Because I'm looking at this, I'm like, hey, is this the same as this? No. Is this the same as that? No. Is this the same as anything in the top? No. So I'm done. Here it comes. Check this out. -2 plus 7 all over. Let's just go -7 plus 2. Notice what I did? So I got -2, +2. +7, -7. You're like, those aren't the same thing. You're right. But wait, let's finish this. -2 plus 7 is 5. -7 plus 2 is -5. Guess what? That equals -1. Why are you showing me this right now? Because this is the same thing. Now watch this. I'm going to take this out, make an X. Take this out, make a Y. That would make this a Y. And that would make this the X. These are what I call exact opposites. Okay? So if you notice, exact opposites are just going to equal -1. So I go, wait, here's a positive X, negative X. +2, -2. I'm not worried about these. These cancel, and they make a -1. Where do you put the -1? Typically in the top. And I can see that these are not the same. So this would be my answer. So that is a stinker, but this is a brand new rule you got to be on the lookout for. Look out for exact opposites. Now, why did I write this down twice? Because maybe a student would go like this. A student might think, you know what, I'm used to like x squared minus 49 or x squared minus 100. So they're going to rearrange this, but you can't just take the negative away from the x squared. So it's -x squared plus 4. I just went, so that doesn't change its value. And that's like, ooh, that looks weird. Okay, here's a trick. We can take out a -1. We're left with x squared minus 4. And then it's like, that's the difference of two squares I'm used to. So the negative comes along to the right, x minus 2, x plus 2, all over. We already factored that. That'd be x plus 5, x minus 2. And now it's like, aha, you did the hard work at the beginning. So now these are the same. And notice this negative x plus 2 all over x plus 5, same answer as right here. Now some of you are like, well, that doesn't look like that. Well, what's 2 plus 7? 9. What's 7 plus 2? 9. So the order in which you add doesn't matter. So this, same answer as this. So the bottom line is, yeah, if you see an advantage, you can factor a -1 out at any time. So, yeah, let me pause something. Okay, if you didn't like my explanation right here, where you're looking for exact opposites, I just did a problem over here, I erased it, but my final words were, you can factor a -1 out of anything you want at any time. But you've got to still look for exact opposites. So this one right here and this one right here are exact opposites. I'm just redoing this one slightly different. Like, you know what? I'm going to take a -1 out of this thing. Well, that would change that and change that. Where does this -1 go? In the front. What are these now? Well, they're exactly the same. If I just flip these like that, that would actually be x minus 2. You can clearly see they're the same. So I'd be left with -1, 2 plus x, all over x plus 5. If you don't like that, you can flip it, x plus 2, but you don't have to. All right. Now, I forgot about this. They're asking you, what's the domain? That's going to be lingering. So the domain means look at the denominator. What can't x be? -5. X cannot be -5. And it can't be a 2. That's x minus 2. Okay? Here we go.